Okay. So yeah, the title of this talk is to do it yourself Gosec. I don't know how many of you are familiar with Gosec, which is a tool to find bugs in Go. And so the goal is to present how to detect complex code patterns using semantic grep. And so if you have any question during the talk, feel free to interrupt me. Maybe we'll not go toward, maybe we will not finish the talk, but it's better to answer questions. So, and yeah, I apologize in advance because I'm not the Go expert at R2C. But my colleagues, most of my colleagues are on the west coast of the US, and they sometimes have a hard time to wake up, and so I'm the one presenting because I live in Italy. So yeah, so what is the goal of this talk? So if you have a few things to remember, is that yeah, writing secure code, as you probably all know, is hard, and static analysis tools in general are very noisy, very slow. And so most developers don't like static analysis tools, which is sad because they're supposed to help developers. And there's static analysis tools and grep, which is a fantastic tool, but isn't expressive enough to find bugs. And so we need something fast that is aware of the code, open source, in between grep and static analysis, and that's what semgrep is. And so that's the goal of the talk, is to present the semgrep tool, which is a fast and syntax-aware semantic code pattern search. And so what are the use cases of semgrep? So the first use case of semgrep is to search for patterns, and the goal is usually to find security bugs, but it can be also general bugs. And another use is to enforce, once you find the patterns of code that you don't like, you can then enforce that the specific patterns do not occur anymore in your code base. And it can also be a little bit used to migrate code, to automatically fix code and to upgrade old code using old API to new API. And so, yeah, a few words about me. I'm Yoann Padioleau. I'm a software engineer at R2C. And R2C is a small startup, mostly based in San Francisco, even though now a few of us are remote. I live in Italy, for example. And our mission is to improve software security and reliability. And so I used to work at Facebook before. I was one of the first members of the test engineering team and the AppSec team and the program analysis teams. And so the outline of the talk is that I'll present a little bit a background about the problem of finding bugs in code. And especially I'll talk about grep and abstract syntax tree. I don't know how many of you are familiar with the term abstract syntax tree, for example. Can you raise your, I mean, I don't know how to make a poll, actually. I don't know if people can chat or okay. Oh, yeah. So, okay. So one of you at least is familiar with abstract syntax tree. And then I'll do a few demo on about how to learn semgrep. And then I'll present how to integrate in your CI or CD semgrep. And then if you have time, I'll explain the semgrep rule registry, which is a set of rules that we've put on the web so that you can explore rules written by other people. And so first, so semgrep. So you can, so the presentation should be available online. I think there's a PDF at the start of the presentation. And so the semgrep tool is on GitHub under the return to corp. And so if you click here, it will go to the GitHub page, and it's open source. And so you can easily download it and test it on your machine. And so semgrep. So I wrote a first version of semgrep. I mean, it was called grep at the time at Facebook in 2009, around 2009, and it was used to enforce about 1,000 rules on the Facebook code base, and the tool was it was for PHP, because that's how Facebook was written. The website of Facebook that's how it is. It's mostly written in PHP, and actually a previous version of SamGrep was written before. I wrote a previous version again of SamGrep for C called Coccinelle. I don't know if a few of you are familiar with it, but it's the tool for the Linux kernel to help refactor code and to find bugs. And so, but right now, so this was a very old version. The first version was written for C and then for PHP, but now it's been changed a lot, and lots of features has been added. And now actually it supports many languages. And so Go, Java, JavaScript. We just actually recently added Ruby, TypeScript, and so the list of languages we support is growing every week. And so, yeah, a few words about grep and abstract syntax tree. And so grep is a fantastic tool to find code, but the problem is that it's using regex, which are great. But I don't know if you're familiar with this famous XKCD strip about Perl and regex. But basically, you say, yeah, if you're having Perl, if you start to use regex, you have lots of problems that are coming. And so, and the main reason is that because code, I mean, regular expression are used to find strings, right? But code is not a string; it's a tree. And so, if you look like on the left, the Python code, it's recorded in a file as a big string, right? But internally, the compiler and many tools don't look at the code as a string. They look at the code as a tree structure, as an abstract, which is called an abstract syntax tree. And so the compiler doesn't manipulate the code as a string, but it knows that there's a function call there, and then there's the argument. So and so there's many tools actually that are better than grep that are doing that try to find patterns in code using tree matching. And so in the Go world, there's a tool called Gosec, Golint. For Python, there's Bandit, Daylint. For JavaScript, there's ESLint. For Ruby, there's RubyCop. There's lots of tools, lots of linters that work actually on the EST level, and so that are more resilient to small difference in the file. And because regex are in general quite fragile. And the problem with all these tools is that each time you have to become a bit an expert in every abstract syntax tree syntax. So, and you need a little bit of programming language expertise. So it's not impossible to learn how to add a rule into Gosec or Golint. It's not impossible, but it is some work. And for example, on the right of the slide, there's an example of a rule for Gosec, and the goal is to find calls to an old crypto API. And so it's only 94 line of code, which is not very big, but you still have to write that, and it's not trivial. And so there's lots of tools like Gosec, and then there's commercial tools. But usually, like, I don't know if you're familiar with for I don't know actually if there's lots of tools for Go, commercial static analysis tools for Go. But for all the languages, like for C and Java, you have Coverity, Fortify, but they're usually pretty complicated. And so slow, complicated, expensive, they cost money, and they're not easy to extend. Usually you cannot extend them. If you have a rule in mind, you have to ask them to support this new rule, and it's going to take some time. And so where is SamGrep? So so this is a slide taken from a presentation by Instagram, that shows the landscape of tools to find bugs. And so on the left, you have like regex based linter, and for example, grep can be used as a linter. And actually, many open source projects, you will be surprised, are just using grep as a way to link code, and it's pretty useful already. And they are easy to use, but they're a bit dumb, right? And they're quite fragile. And so, for example, you can find in Python all the definition of a function with this regex, but if you have new lines, or it's not gonna be super resilient. In the middle, you have ST-based linter. So Gosec is in the middle that understand not that see the code as a tree. And then on the right, you have whole program analysis, that are far more complicated, usually slower. And so for Python, you have, like, for example, the MyPy type checker. For Go, I think there was this guy called Donovan that wrote quite complicated analysis for Go, for alias analysis and this kind of stuff, data flow analysis. And so that's the spectrum. And semgrep is there in the middle. It's not dumb, but it's still pretty easy to use. But it's not all program analysis, so usually it's pretty fast. And so that's the place where we have semgrep. And so semgrep lets you reason about your analysis the way you reason about your code. And I'll show that what it means in the next few slides with a different demo. And so I'll present a few demos of the power of semgrep. I will explain the ellipsis operator, meta variable, and the way to compose multiple patterns. And then I'll show more advanced use of semgrep. And then yeah, so let's dive in. And so here is a quiz. And so how would you find and ban a deprecated function? So that's just the use of the RC4 model. And so here you have some example of code, do RC4 cipher with a key, another key. And so you would like to write a rule to prevent this code in your code base. And so here I click on the link, and semgrep is a command line tool, but we also made a UI so that you can easily experiment and try rules. And so here you have the code at the bottom. You can change the language also here. You can load different examples. So you can play with it after the presentation or during the presentation, whatever you want. And here you write the patterns that you would like to find. And so one of the big idea of semgrep is that we don't want to know how things are represented internally in the abstract syntax tree, because each language a call will be represented by a call node or a function call node, or each tool has a different convention for naming. But the main idea of semgrep is that you already know how to express patterns in Go or in C. You already know the language you use. And so the idea of semgrep is that let's just use the syntax of the language you know. And so if you want to find calls to RC4 new cipher, you just write the code like this. You don't need to know how a call is represented. And you write RC4 new cipher. And then you don't care about the argument. And so we have this special operator, ... that means we don't care. And so you write this pattern, you type run. You can also do that on the command line. It's just like it's easier for presentation and also for development in general, to develop the rules with a web UI. And so once you write this pattern and you run it, on the right you have the different match. And here you can see that it matches the 3 calls to RC4 new cipher. And also what's important is that, for example, here there's a method called incomment, and we actually don't match there because like I said, semgrep is not grep. It is aware of the code, so it is aware that this is a comment. We don't care about comments. Or for example, here there's another there's another mention of RC4 new cipher in a string. Again, this is not what you were looking for. Here you were looking for real code, not string comments. And so and in the same way, here you can see that there's different spaces. The tool, it doesn't care about spaces. It works internally on the abstract syntax tree. So for example, here I put a new line, I run the tool, it will still match there. If I put comment here, blah blah blah, it doesn't matter because internally it's working on the abstract syntax tree. And so that's the first demo. I don't know if people have questions already, or otherwise I can continue.
I don't see any, so when I notice, I will interrupt.
Okay. And so the second feature of semgrep, so the first real feature of semgrep is that you can just use the syntax you already know. And so you can express complex code patterns just writing the code you're looking for. And you have the ... operator, which is a way to abstract away a sequence of arguments, of parameters, and so on. And so here, there's another example of code you would like to find. You would like to find all the code to the unsafe model here. And so you don't actually care about the method, its pointer or size of. And so the way you do that with semgrep is that you write unsafe, and then you use a meta variable. And so a meta variable is a variable that is prefixed by $, and then a series of uppercase later. And it means any kind of expression or identifier, or so it will match any name for the method. And so you use unsafe.ref, you run it on the code, and it will find the 3 different instances. And so with these 3 features already, and so you can use, with the 3 features already, you can already express lots of rules. And here another example is that you want to find insecure SSL configuration. And so you have this call to the config where you have the mean version that is a wrong version, and you set also this field to true. And so the way you do it with semgrep is that you can not only write simple patterns, but you can also do Boolean composition of different patterns. And so here, instead of a single pattern, we can actually have in YAML, in the YAML syntax, a different set of fields. So here we have a set of rules. So that's the name of the rule here, the message to display when the rule matches, some metadata, the language that was used. And here you have, like, here you see you have a combination of patterns. And so here it says, when you have the TLS config with this field, or that's the pattern either, or this field, and then we want to display a message. And so if you run it, it will tell you, yeah, there's a SSL v3 is known to be broken, use it with care, blah, 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 at the different places, here and here. And so you can use and, or, not. So you can write these simple patterns, and then you can compose them with complex Boolean expression. And so that's the main feature of semgrep for expressing patterns. And so here I just described simple expression, but you can also match complex statements, definitions, fields. You can write any Go code, put some $ here and there, and some ... between elements, and then we will do the matching on the EST and find the occurrence of the pattern. And so now I'll present a few other uses of semgrep, not just to find security bugs. And so the first one is to find anti-pattern. So it's not really security bugs, but it's things that you should not do. And so there's a blog post actually about it. So sometimes you can have hidden Go routine, and where you have like a Go, an internal Go func inside a cleanup, and you would instead prefer to do it that way. And so the way to solve that with semgrep is that, right, when and it's not this code, then display a match. And so here I've shown, like, there's a you can write either with the editor, you can either write your rule in the YAML format, or you have this simple UI to help you a little bit manipulate Boolean patterns. And so here you run it again. So you're looking for a function. You don't care about the name. You don't care about the parameters here. And then inside there's a call to the Go, a special built-in. And then you don't care. But if there's more code here, then it's okay. And so that's why it will find this one, but it will not match this one, because here you have some other code. And another use case is instead of finding security bugs, is to find business logic problems. And so, for example, let me click on the solution. I'll go directly to the solution here. Is that sometimes you want to make sure that you call a certain function before another one. For example, you want to make sure that you call, when you do a make transaction here, you call verify transaction before. And if you just do make transaction, we want to display an error. That's why the rule is that when your code is that and it's not this one, then find a display a match. And so here it's a bit subtle, but we reuse the same meta variable here, $t, which means it will be enforced that they must be the same, because you can have in some code you can have multiple verify and make with different expression, and in this case it's okay. I don't know if there's any question. Feel free to interrupt if you have some questions.
Yeah, talk is very interesting, but I don't see any questions so far.
Okay.
That's a nice example. This one is a really nice example.
Yeah. So you have like the function. We don't care about the parameter. The make transaction can be anywhere inside the function, but we want to make sure that there's a verified transaction before. And by using those patterns with this Boolean logic composition, you can express quite complex stuff in here. And so, yeah, I'll now expose a few advanced features that has been added in the last few months. And so you can use SameGrep to enforce rules. Sorry. And so, but you can also use the API of SameGrep to make other tools. And so I'll present one of these tools, but there's this problem where you have like a big code base and you would like to do a code asset inventory. You would like to know, for example, what are all the routes to your website and whether or not they are secure, whether or not there's an authorization protocol inside in the different routes. And so here's the link. And so what you can do is that with SameGrep, you can for any call to the route that any app, and then there's a router handle func. You don't care about the route, you don't care about the handler, and with the method and with a meta variable there. And the goal is to each time capture a subpart of the expression in the meta variable. And so here, if I click on here, you will get into the root the slash product. That's the first argument. In the handler, you will get a.get product, and in the verb of the method, you will get post get. And so you can use SameGrep to express this pattern, and then you can plug that in another tool that then agglomerate all this information and can display some graphs. And so one of our colleagues made one of these tools, and so he's using this pattern and then wrote a simple Python program to use these routes and then to display a nice graph of all the different routes in your website and with different colors, whether or not there's authorization in. And I don't exactly remember the color scheme, but you get the idea that SameGrep can be also used by other tools so that you can use the power of SameGrep to extract code and then do any kind of statistics or metrics on your code. Another feature, it's Autofix. So it's very good to find bugs. It's even better to fix it automatically. And so here, for example, there's if you call the TLS with an old version, then we would like to automatically fix it to the new version. And so here, grep. So this is a rule, SSLv3 in this and the pattern is this. So you have a call to TLS config. You don't care about current field, but there's a field that is called min version, and you don't care about the variable $TLS, but there's this specific version, right? And the fix here is to use install TLS13. And so if you run it on this code base, it will find a match. And on the right here, you actually have the automatically fixed code. And so you can click on apply the fix. I cannot right now because I have. Let me move. I can. Now it's on the top. I moved the zoom. So you can use apply fix, and it will apply the fix on the code here. And so this is on the web UI, but you get a similar thing with the command line tool where you will get the fix. You can say yes or no, and it will apply the patch. And now, how do I move that to be back here? How can I move back the zoom toolbar to be on the right? Does anybody know?
You can always stop sharing and start sharing.
Okay, let's see. Okay, so this is Autofix. So now you can find bugs and automatically fix some of these some of those bugs. Another feature is that so the core of semgrep is written in OCaml, but actually there's a wrapper around it written in Python, and so you can actually write. You can extend semgrep by writing any kind of Python expression. And so here you express a complex pattern. So you say, oh, we are inside a class, and when you have this pattern that you call Django, so this is Python, a Pythonable. Sorry for not using Go for this example, but you use this pattern, and then you would like to make certain condition on the price. And so you can write here pattern where Python, and you can write any expression. And inside this expression, you can reuse the meta variable that were matched before, and then do any kind of computation on it. So you can. So let's if I put an example here, let me click. Here you have an RSA keys, and it's using a certain number of bits, and you want to make sure that those bits are less than 2048. And so if you run it there, it will find this one, which is indeed less than 2048. And so the way it works is that the pattern is here, and so it matches this code, and then it binds the $bits meta variable to the value, which is 1 and 24. And then in Python, we execute this expression, and if this expression succeeds, then it's a match. If it doesn't succeed, then we say no, it's not a match on this one. And so it's a way, because the semgrep allows you to write code and meta variable and ellipses and so on to match code, but you don't have the full power of a real programming language. You cannot, for example, in Gosec and Golang, you can use the full power of Go to write your rule. And so that's a way to a bit extend the power of semgrep by using Python. We could actually also allow to do write the expression in Go, or we could embed a Go interpreter, or I don't know if there's one actually, but anyway. And so yes, another important thing is that you want to develop your rules locally, but then you want to enforce them in your CI, in your continuous integration system. And so it's pretty. So because you want to enforce secure default, and you want to have secure framework at CI time. And so it's pretty easy to configure your project to add semgrep in your CI, so that every time you make a pull request, then we can automatically run all the rules you have written, or rules written by other people, on your code. And so it's pretty easy. So actually, I can show you even on the website here. is that you can click on the deploy. I need to move this again. Sorry, you can click on this part, and this rule now is live on the web. And so with this URL, you can pass this URL to the command line tool here. You can say semgrep --config and this URL, and now you can run this this command on your own project locally. Or if you use pre-commit or GitHub or GitLab or Secure CI, you can just copy paste this snippet in your CI config file. And so in .github / blah 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 workflow.yaml. I never remember. And so you put this these snippets here. You can see the URL, and then every pull request you make, semgrep will enforce that all the rules you have written or that you use are respected in your code. And so that's the integration with CI. And so once you've configured your CI, if there's an offending some code that matches one of the rules, and then in your CI you can click on the semgrep action, and then you will see the error here. So for example, here it tells you that at this line, this rule was the python.flask.security injection rule was flagged. It's zoomed out a little bit here, but you get the idea. It automatically tells you where it is. And actually, we are working also on some integration with VS Code, so that you can even have semgrep running in your editor. So that's pretty cool. And yeah, one last important features of the semgrep ecosystem, because there's the semgrep, the command line tool, there's the semgrep, the web UI to let you develop a rule. There's a semgrep in your CI, and there's also what we call the registry, which is a set of rules written by the community that you can use in your project. And so so the idea is to have like the different communities, the Python community, the Go community, to write rules for their language. And so we can then, every project can share their rules, and we have a more secure software. And so we have developed ourselves 100 rules, and we have also, I don't know if you're familiar with this tool called Node.js Scan, which is a tool for JavaScript. And so the Node.js Scan tool, actually, the author, Ajin, migrated all his engine to use semgrep. And so now all the rules in Node.js Scan are actually powered by semgrep internally. And we have actually ported many of the Gosec and FindSec bugs rules to semgrep. And so it doesn't take much time actually each time, so to port those rules, which is great. We have the Django core creator who contributed some rules. And we have independent researcher that wrote some rules. And actually, yeah, in the Go community. So I don't know if you know Damian Grisky, is the author of the Go perf book. And so he actually has written many rules. He has contributed many rules for Go. And so there's a few examples here of rules that have to do with bit shifting and bad ifs and weird expressions. So feel free to go to the semgrep-rules website, and you will see the different rules he has written for Go. Oh, sorry. And so once a rule is available, so yeah, lots of those rules are available on the return to corp semgrep-rules repository. So I can click on it. So you can actually, anyone can make a pull request to this repository and add a rule for different languages. And so as you can see, there's some rules for Go, Java, JavaScript, Python, Ruby, and each time like they are separated in different topics. So security, audit, for Go, there's mostly security. And once you have like once instance semgrep rules, you can just on your machine you can do brew install semgrep, and then semgrep -- config with a URL, and then it will run on your code. And then what you can do is that you can make your own configuration. That is, we have all these rules, but maybe some rules don't apply on your project, or you don't want them to be flagged on your project. And so you can have so we have different packs. And so, for example, there's a Gosec pack, so you can use just these packs of rule, but then you can mix different rules together. And so again on the web, we have an interface to let you compose different rules and make a rule set for your own project. And so what is coming soon? So we have actually support for TypeScript, which is in alpha. So we just added that last week. We are planning to write many more rules, and to get more and more people from the different communities: the Go community, Python community, JavaScript community, TypeScript community, to help us contribute more rules. As I said in the presentation, we have like a Visual Studio Code extension that is in beta, so you can run all those checks from your editor. And we have different advanced features that are in alpha support. So that we have some support for tainting, for expressing different code equivalents. We have a few more features in the work. And I think that's it. So semgrep, a lightweight static analysis tools for many languages, including Go, which is what you are most concerned with, I guess. And so to install, you can do just brew or pip, because a big part of the tool is written in Python. Install semgrep, and then semgrep -- config to use a set of rules. And I can answer questions if you have any.